Alright, this is still 3-6. I'll put that at the top here. So it's section 3-6. Remember, we kind of split it in half. We were supposed to get to it yesterday, and we had so much problem with that one problem yesterday. We took almost the whole time, so I'm going to do that today. Alright, so section 3-6. It's very, very close to what we did yesterday, just with slight little modification, if you want to call it that. We'll make these lines red, if that helps. So what we're going to do is graph these two lines, all right, to see what's going on. Now, do you absolutely have to graph them to get these problems right? No, you don't, but I'll tell you what, I've taught this for a lot of years, but it helps me, all right? So if I was to actually solve it, if somebody gave me a problem and said, hey, find the length of this between these two lines, I would actually graph the thing out, okay? I really would. So that's what we're doing, by the way. We are finding the distance between these two lines. So what did we do yesterday and the day before? We found the distance between a what and a what? Yes, a what and a what?
A parallel line and a perpendicular.
Well, just a line. Doesn't have to be a parallel line. Right. Well, just a line and a point, right? A point and a line. Okay, so what we found before was the distance between a point and a line. All right? But now what we're going to do is we're going to find the distance between two lines. Okay, and they're going to be two parallel lines. All right, because if they weren't parallel, there'd be a lot of different distances, wouldn't there? Because if the lines, watch this. If I had a line like this and a line like this, and I said, find the distance between these two lines, well, that's closer than that, right? So how do I know which one to find? I don't. So what do you think is going to be true about the two lines? They're going to be what? They're going to be parallel because it's the same distance no matter, right? No matter what point I pick, the distance will be the same. All right, so find the distance between two lines. Two parallel. I'll put the parallel sign there. Two parallel lines. All right? So that's what we're going to do. And here's two lines. How do I know without even graphing them that they are parallel to each other? Same slope. Very good. Okay, they both have a slope of 2. So you know just by looking at the equations that those two lines are parallel to each other. Agreed?
Will they always be parallel?
On these problems they will, yes. Yeah, because you can't really find, there's not just one distance between two non-parallel lines because it changes. Everywhere you go on the line, it changes, okay? So you couldn't do that with non-parallel lines. They have to be parallel to do what we're doing. All right, so let's graph this. So this one is y-intercept at 1, right? And the slope is 2, so rise 2, run 1. Now if you're graphing these, sometimes if these are a little too close together, you ever do that with a ruler, put a ruler on there? You think it's right, but then you extend it out, and it's off a little bit as it goes up further. You ever do that? So let's do this. Let's go 2, 1 this way. Do you see what I'm doing? 2, 1 this way. 2, let's see. 1, 2, 1. Did I go 2, 1? 1, 2. Oh, I went 2, 2. What am I doing? Stop the train. All right. So watch. 2, 1. There we go. And then what? 2, 1. Yep, that's right. And then watch. Rise 2, run 1. That's what I was doing. I was running and then rising. Got to rise, then run. All right, so anyway, sometimes it's helpful to put several different points on there just to make sure that your lines line up. Because when you put your ruler, if the points are really close together, do you know what I'm saying? If the points are really, really close together and you put your ruler there, sometimes that's not very accurate. So you want to kind of stretch those points out a little bit to make sure that your line is pretty accurate. Right? Now again, you don't have to be accurate with this. You really don't. But it's just kind of nice. Alright, so there you go. So there's our nice line. And what about the other one? Right, go down to -3. Good. 1, 2, 3. And then same thing. Up 2, over 1, right? And we'll do that a couple times just to make sure that we get the nice good slope here. 2, 1. Is that alright? Especially if you're not using graph paper, it's really helpful to maybe do that. Alright, so this slopes like this. Oh, that wasn't very accurate. Let's try that again. Well, the two parallel lines you definitely want to draw, yes.
No, like the two little arrows.
Oh, no, you don't have to put the arrows on there. It's not that big of a deal. Alright, that's pretty close. So even though I'm using this graph paper and using this computer program and all that, sometimes it could still be off just a little bit. But it doesn't have to be perfect. This is just to give us an idea of what we're trying to find. Okay, it's just a picture to see what's going on. And I want to find the distance between this line and this line. Well, it's really not a whole lot different than what we did yesterday. Because what we did yesterday was we found the distance between a point and a line, correct? So what I'm going to do is I want to take a point on this line right here. And what point do I absolutely, without a shadow of a doubt, know exists on this first line right here? What do you think, Alex? The y-intercept. Perfect. That's a great place to pick. You could have picked this y-intercept because that's a point. So you could find the distance between this point and this line, right? Or you could have found the other y-intercept, right? Found the distance between this point and this line up here. Tell me something about those two distances. What do you think might be true? Let me make it green. It should be equal, right? Shouldn't matter. I could take any point on one as long as I go perpendicular. Does that look perpendicular? About like that. That distance right there should be the same exact distance as if I went from here to here. Perpendicular. Everybody see that? Well, that shouldn't have gone all the way to there. Okay, good enough. Question. Alex? Well, I wouldn't just pick any old point though. That's the thing. Yeah, I would pick one of the intercepts. Okay? So I'd pick either this point, okay, or I would pick this point right here. Okay, that's the whole idea behind this. Okay? You could have actually picked this point right here because look, I know that I started at 1, so what was my slope? It was up 2 over 1, right? So I actually do know what that point is, don't I? On that line. Do you agree? What is that point? It's what? It's 1, 3. So I could have picked this point and gone perpendicular this way. All those distances would be exactly the same, wouldn't they? But I kind of think it's easier to do the intercepts. I just think it's a little bit nicer, a little cleaner. Plus, you get a 0 in there. And sometimes 0 helps you out a little bit. Makes your math a little bit easier. Wouldn't you agree? All right, so let's do that one. Let's forget this one. Let's just do this distance right here. It's kind of an ugly green. Let's change that to a nicer green. Is there a nicer green? How about that? I couldn't tell any difference. All right, whatever. It doesn't matter.
Mrs. Wicker.
All right. So, that was kind of random. So what are we trying to do? We're trying to find how long that little line is right there, that little green line. That's what we're trying to find out. All right. So now we're kind of back to what we did yesterday, aren't we? Finding the distance from a point to a line. The nice thing about this is they tell you the equations of both of these lines. So I don't really have to do a whole lot of work, do I, to find this equation of this line right here. What is it? Y equals 2x minus 3. Good, Kenny. All right, so it's y equals 2x minus 3. That's this line right here. Okay, what's this point right here? This point right here. Daniel, what is it? 0, 1, right. Okay, because that's the y-intercept of that other line, isn't it? So I know that point is 0, 1. So let's put a 0, 1 right there. See what we're trying to do? So what I'm trying to do is this. I'm trying to find the equation of this line, and I also want to find the equation of the green line as well. Right? Isn't that what we did yesterday? Let's make this red just so that it's kind of color coordinated there. All right? So there's that red line, and then it sounds like I'm saying red lion when I say that, red line. And then let's put an arrow way out here like this. And then I want to find the equation of this line right here. That's actually very, very easy. Why is that very easy? Because I should know the slope of the green line. Because remember, if this is the distance, it's got to be perpendicular, right? So what was the slope of this red line right here? 2. Or it was just 2, right? And what's the slope of this green line going to be then? Is it going to be 1/2? Negative 1/2, right? It's going to be negative 1/2. So the slope is negative 1/2. Agreed? I already know what the y-intercept of that little green line is, don't I? Because I picked the y-intercept. Alex, remember you said, could I pick any line, any point on this line right here? Yeah, you could have, but it makes it so much easier picking the y-intercept for us. Would you agree? So I know the y-intercept already of the green line because it's the same as this top red line. So negative 1/2 x, what? Plus 1. So remember what we did yesterday? Put them in boxes, didn't we? Remember that? And what do we do with those two boxes? What are we trying to really find here? Let's go different color. We're trying to find that point right there, aren't we? Right? That's the point that we're trying to find. And how can we find that point? By taking these two things and setting them equal to each other. Exactly right. So let's do that. Let's go 2x minus 3 equals negative 1/2 x plus 1. And let's find what this x is. All right? And then once we find what x is, we can plug it into either one of these and solve for the y. And then we can find that point right there. That's what we're trying to find. All right? So how are we going to do that? Add a 1/2 x to both sides, right? And then add a 3 to both sides. Do you agree? All right, so that adding a 1/2 x cancels that out. Adding a 3 cancels that out. This is 2.5, or this is 4 over 2, right? Isn't 2 the same as 4 over 2? So what's 4 over 2 plus 1 over 2? Just not talkative, or you don't know? 4 over 2 plus 1 over 2. What's that? It's 5 over 2, isn't it? Okay. 5 over 2x equals, what's this? 4. Everybody with me on that? Now I've got to get x by itself. Dominique? Because the slope of the green one is perpendicular to the slope of the two lines are perpendicular, so the slopes are the negative reciprocals of each other. So I looked at this slope, saw that it was 2, so the slope of a line that's perpendicular to it has got to be the negative reciprocal. So I take the opposite sign, which is negative, that's why I put negative, and it's the reciprocal of 2, which is 1/2. That's how I got this slope. Alright? Got the y-intercept because look at the green line. It crossed right here at this point, and that's the y-intercept of the other one, so it's at 1. Okay? So let's keep going with this. We're almost done finding x anyway. So multiply by 2/5, multiply by 2/5, and x is, what's that? Just 8/5, right? I tell you what, I would keep it as a fraction, to tell you the truth. All right, I think it's a little bit better to work as a fraction, so I'm going to keep it as a fraction. Maybe at some point we'll, maybe when we stick it into the distance formula, we may want to change it into a decimal. But for right now, let's just keep it a fraction. All right, so that's the first half of this point. It's 8/5. Well, what is 8/5? 8/5 is what? 1 and 3/5, right? 1 and 3/5. So where is this point? Well, I went over 1, and look how much further I go. Okay, I went over 3/5. It's a little more than halfway, isn't it? Everybody see that? Because halfway would be 2.5 or 2.5/5, wouldn't it? Yeah? Okay. So it's a little bit more than halfway. How far up do we go? I'm not just going to guess, am I? All right, I'm going to actually put the numbers in and find out. So x is 8/5. Where am I going to put that x? Well, I could put it in for the x in this formula, this equation, or I could put in the x into this equation. It doesn't matter which one you put it into. You'll still get the same exact value for y. Right? And why is that? Because they're both equal to y, aren't they? So it doesn't matter which one you put it in, you'll get the same value for y. It doesn't make any difference. All right, that's kind of cool. So look, let's put it into this one. This one seems a little bit easier. I don't have to worry about a negative 1/2. So let's put an 8/5 into this. Actually, 1/2 might be actually a little easier because then the 2 will cancel out with this 8. I don't know. Which one do you want to put it into? The 2x minus 3 or the negative 1/2 x plus 1? I'll let you choose. The negative 1/2 x? Okay, let's put it into that. So y equals negative 1/2, right, times x. What's the x? 8/5, and then plus 1. See, it really wasn't that bad putting it into this one because look what happens. The 2 cancels into this how many times? 4. So what is it? Negative 4/5 plus 1. But I'm going to rewrite 1. If I'm going to add them up, I want to find a common denominator. How would I rewrite this 1? If I'm adding it to a negative 4/5, write it as 5/5. You got it, okay? Write it as 5/5. Does that make sense? Everybody see that? It's just common denominator stuff. So negative 4/5 plus 5/5 is what? 1/5. So what's this point right here? It's 8/5. What? 1/5. I would have never been able to just guess that. Even by using graph paper, would I have been able to guess where that point was? Remember yesterday, the point on, remember we did all that work, but that point lied right where we thought it was supposed to be, right? But sometimes it doesn't. Sometimes that point doesn't lie right on exactly where you think it's going to be. So you do have to go through that math, and we discussed that a little bit yesterday. All right? So that's that point right there. So all the work was really to find that point. What's the final step here? Find the distance, right? Use the distance formula. So let's write down the points again. 0, 1, and 8/5 and 1/5. Now, I'll tell you what. Here's a chance where I think it would be a good idea to probably put this as a decimal. All right? So 8/5. Well, multiplied by 2, that's 10, so it would be 16/10, which would be what? 1.6? Is that right? Put it in a calculator. Put 8 over 5. It's 1.6, right? Just trying to get you to think beyond the calculator, all right? What about 1/5? What's 1/5? Times 2, it's 2/10, right? What's 2/10? 0.2, right? Did you need a calculator for that? Nah, I don't think you needed it, all right? Now, did you use it? Of course, because everybody's in love with your calculator, right? I like them too, but there are times when you don't have to use it. So now, let's do this. Let's put it in the distance formula. This is our last step. All right, let's put it in here. What do we do? Subtract the x's, right? So 1.6 minus 0 is just 1.6. Now, I may put that into a calculator. What about this? 1 minus 0.2. Can you do that in your head? What's 1? One full number, right? 1 minus 0.2. 0.8, right? Yes? I'm just going to put it right there. Will you know where it came from if I put it there? Okay, it's 1 minus 0.2. Now, I may put this into a calculator at this point. All right, 1.6 squared. Somebody do that for me. 1.6 squared. Say it again. Right, 2.56, because 256 is 16 squared. So it's 2.56 plus 0.8 squared should be what? 0.64? Is that right? And then, I don't know, this probably doesn't come out nice and even, but you put that in a calculator. What is that? Give me 2.56 plus 0.64. That would be what? That's a 0, that's 11, that's a 2, that's a 3 point what? 2, just 0.2, right? Okay. And then, go ahead, stick that in there, put the square root of 3.2, tell me what you get. Okay, let's round it to one place, so it would be what? 1.8, wouldn't it? Okay. Let's not put equals here this time. This is not, is it exactly 1.8? It's approximately. So we'll put the little squiggly equal signs there to show approximately equal to 1.8. And that's it right there. That is the distance. What did we just find? That's that distance, that little green line right there. Okay? Yep. Yeah, you could have put fractions in there. Yeah, absolutely. Okay, you could have put 8/5 and then squared 8/5 and then put a 2/5 in here, right? So 1/5 minus 2/5 is what, 3/5? Or is that right? No, that'd be 5/5. That'd be. Is that right? 1 minus 0.2. I'm sorry. Oh, the 2/10. What am I doing? Oh, it'd be 1/5, wouldn't it? Right. So yeah. So it'd be 4/5, right? So it'd be 4/5. You could square 4/5. Yeah, you could absolutely use fractions on this. Yep, absolutely. Whatever's easiest for you at this point. But you're going to stick it in a calculator anyway. Take a square root. You're going to end up with a decimal, aren't you? All right. So it's not exactly 1.8. It's approximately 1.8. So that's how you do it. Really, it's almost a little easier, isn't it, than the last thing that we did, almost, because it was really easy. They told you what the equation was right here. I didn't have to do any work to find the equation of this line. Remember yesterday? We had to do quite a bit of work to find the equation of both lines, didn't we? On this one, it really wasn't that hard because they told you what the equation of this line was. The green one wasn't that hard either because you just look to see what the slope is. You can automatically see where the y-intercept was. So it was a piece of cake finding this equation and this equation, wasn't it? Whereas yesterday, it was quite a bit of work to find both equations of the lines. It wasn't that hard, but it was a little bit of extra work. But now we got both equations. You set them equal to each other, right? Set them equal to each other, and you got your point. Once you have your point, you throw it into the distance formula, and then you're good to go. What do you think? Yes?
Will they usually be like that where the point is like 8/5 and 1/5?
As far as what? Like not coming out real nice and even?
Yeah. Are you ever gonna do this one?
I don't know, because I don't make them up. So it's whatever the book does. There might be times, I don't know for a fact, if there's times where it comes out to be a nice whole number. In that problem we did yesterday, it did, right? It came out to a nice whole number. But I did warn you yesterday, though, didn't I? That it's not always, this point's not always going to come out to a nice, perfect, whole number, over and up. It could be fractions, could be decimals. And in fact, this one actually did come out like that. So it could be one or the other. It could be, whatever. But just be ready for it either way. Does that make any sense? All right, so that should help a little bit. All right, let me give you a few problems to work on with this. We'll give you, I'll give you that quiz on Monday, since a lot of people aren't here today. It's a lot easier, and there's still a few of you still have to make up that other quiz, right? Some of the couple of the eighth graders, like about 3 of them. Yeah, you could take it now, because what do we get out of here? It's Wednesday, 20. Yeah, we got 15 minutes. So, yeah. So the quiz is going to be 3. Here, watch this. Everybody look up here. Everybody look up here. The quiz is over sections 3.3 and 3.4. So it's not even this stuff. It's not even this new stuff that we're doing. Okay, it's older stuff. It's a little easier stuff. Dominique showed me a worksheet that she printed out. I actually have all of Chapter 3's worksheets on digital lockers. So if you want to, now unfortunately the answers on there, but the worksheets are on there, and you can kind of get an idea of some extra problems if you want to see some extra problems. You could always come in, look at my answer book. I got an answer book for you. You could always look at it to see how you did. So that's on Monday. All right, I'll put the homework down just in a second here. Let's go dark purple. Yeah, here's your homework. Your homework is page 219. So what I want you to do, I just want you to add this to the other one. Remember the other one? You had like up to 20, like what was it, 15 to 20 or something like that? So just add this to your other one. So this is 21 to 29. So basically it's 10 to 29, okay? I think 10 or 15. What was it? 15, sorry, 15 to 29, okay? So it's like 15 to 29. So you're basically doing the second half. I'll give you 10 points for it since it was over 2 days. All right. And it is a little bit of work. All right, so there's your homework right there. And you got plenty of time this weekend. You got a long weekend, don't you? All right.